that you're looking in. Tangent of x equals -1. You wrote something about sine and cosine. There's only 4 places on the unit circle where well, there's more than that, but there's some places in the unit circle that are really well known for tangent. So I'm just draw the unit circle here. At 45 degrees, the tangent is 1 there. Okay,
Oh,
and
okay.
if I go this way, if I go 135 degree, I'm sorry, 215 degrees, it's on the same line. This line has a slope equal to 1. If I go this direction where the slope is -1, okay, that's what we're looking for here. So it's there's 2 angles. It's this one to get us to right there, kind of 45 degrees between these two. So that's 3 pi over 4, comma, if you go all the way around, that's 7 pi over 4.
Okay.
There's really no work for this beyond that.
Yeah.
Okay, part B, assume you want to do that, so we'll snip that in. Part B uses the zero product property. This is something you learned in previous classes. In short, you just set each of these equal to 0. Cosine x plus 1 equal to 0. 2 cosine x equal to, 2 cosine x minus 1 equal to 0. And then you solve each of these.
Oh, okay.
Okay, so the first one we're setting cosine x equal to -1. And then we'll solve that. So cosine x equals -1. Again, that's a unit circle place. Cosine is the x value. So it's where is the x value equal to -1, and that's right there. So you just say x equals pi for that.
Okay.
On the right, you solve for x and you get cosine x equals 1/2. And these are all from your unit circle. Do you have a unit circle handy, or do you send you a link? What would help here?
Yeah, I have one in front of me.
Okay, great. So the cosine x is 1/2 here. It's the x value, and then there's one here, and you need the x value there. So the angle for that is pi over 3, comma 5 pi over 3.
Got it.
All right. Um, that takes care of that one. We'll move to part C. Part C says 4 sine squared x. Okay, a couple of ways to do this. One is to do difference of squares, and difference of squares meaning this, a squared minus b squared. Another is you just solve for sine x. Which way would you prefer? Which way do you see this problem?
Just solving for sine x makes more
Okay,
sense, I think.
so sine squared x equals 1/4. Add 1, divide by 4. Then you take a square root of both sides, plus or minus. That's very important. So sine x was plus or minus square root of 1/4. And that becomes plus or minus the square root of 1 over the square root of 4, which is plus or minus 1/2. So you're really solving two things. Where is sine x equal to 1/2? Where is sine x equal to -1/2? You'll see me do this over and over again. I'm just drawing a unit circle. And there's these places, and this is where the y value is -1/2.
Okay.
Okay, so -1/2, that's here and here.
Okay, so I got 11 pi over 6 and 7 pi over 6.
Yes.
And then for positive 1/2, it's pi over 6 and 5 pi over 6.
Exactly. Yeah, I'm sorry. I did it for the negative, and there's
Okay.
So yeah, so pi over 6, 5 pi over 6, 7 pi over 6, comma 11 pi over 6. Okay. Without having a unit circle, it's pretty tough, but that should take care of that. It's okay.
Okay. So I think I got everything up to, okay, number 9 is the next one.
Okay. Number 9. All right. The ladder leaning against a wall.
Yeah.
Great. All right. Is this the calculator portion of the
Yes.
exam? Okay. 12-foot ladder is leaning against a wall. If the foot of the ladder is 1 foot from the wall, what angle with the ground does the ladder make? So you have a picture, maybe. Yes, you made a picture. I'm going to draw it in the same way that you made it. So the 12-foot ladder is here, 1 foot against the wall. What angle does the ground make with the ladder? So you're trying to find, I'm going to label it here. I'm going to call it A. So there are 3 trig functions: sine, cosine, and tangent that you generally use here. More generally, it's so, katoa, or there's other variations on that. This tells you which sides you need for this angle. So like relative to this angle, 1 is the opposite and 12 is the hypotenuse. Do you agree with that? Is that okay?
Yeah.
So the sine of A equals 1 over 12.
Okay.
Because 1 is the, I'm sorry. I'm sorry. I said many very bad things there. The cosine of A is 1 over 12. The adjacent, I don't know why I said that, but the adjacent is 1 and the hypotenuse is 12.
Yeah.
Okay. Now, normally maybe you're used to being given the sides. Are you given the angle to find the sides? You have to undo cosine to find. You have to undo cosine to get the angle. So A equals the cosine inverse of 1 over 12. You have to make sure your mode is in degrees. Your answer might be correct. It may just be a matter of you didn't show this one of these 2 steps here, believe it or not.
Yeah.
Like you didn't label the angle, because I think 8.3 sounds reasonable given how steep that is. No, it's I'm sorry.
Yeah, no.
It's 85.2 degrees. I was thinking
Yeah.
the other way, 85.2 degrees. Is that clear now?
Yeah, that makes sense. I had no idea what to do.
Yeah. Hopefully it's clear now. So um, all right. I assume we're going to do 11 next, or 10? 10?
Yeah, 10. It's just 9
10.
through 12 at this point.
Okay. Let me just move this down. Grab 10. All right. Standing 100 feet from the base of a building, you look up from the horizontal at an angle of 50 degrees. Okay, so I like your picture here. There you have a building, and it's 150 feet, and you see an angle of 50 degrees to see the top of the building. How tall is the building? Okay, so we're trying to find the height of the building.
Mm-hmm.
And relative to this angle, this is opposite, this is adjacent. So it's SOHCAHTOA. The one that uses the opposite and the adjacent is tangent. So tangent of 50 equals the opposite, which is h, over 150. So h equals 150 tangent 50. And that goes in your calculator. You use sine. Sine would have worked if you had the hypotenuse, which you did not. You had the this length here.
Yeah. Okay, I got 178.7.
Yes, 178.7 feet is correct.
Okay. All right, now we can do 11.
Okay, so scrolling down here to 11. You've got to draw a triangle. It looks like you started that process of drawing a triangle. 11 is here. So that's A. So, okay, so let me label it the way you did, kind of. Okay, you put A at the top. Is that generally how you do it?
Yeah.
Okay. I just want to do it the same way because it'll be helpful. So A, B, C is what you do. Okay, so this is 25 degrees. This is 110 degrees. And little b is 60. And you're supposed to find side A. So this is a law of sines problem. I remember now when we did the review, we kind of went through this pretty fast. Law of sines requires an angle side pair. So do you see how you have an angle and a side pair together?
Oh, yeah.
And here you have an angle and you're trying to find the other side pair. So you're really like, that's the best case scenario. So the way it's set up is actually a bunch of different variations on it. It's A sine big A over big, or B sine big B equals C over big sine big C. And you can use like any, you can set like these two equal, you can set like these two equal, or you can set like these last two equal, or first and last equal. But you generally have three of the four pieces. So here you're trying to find A. You're trying to find A over sine 25 because big A is 25 equals B. B is 60 over sine of big B, which is 110 degrees. So this right side is a number. This is a number. So A is 60 sine 25 over sine 110. And if you wanted to, you could round these to like 4 decimal places.
Okay. Just gotta put it on my calculator.
Mm-hmm.
Okay, I got 26.98. And that's the length of side A.
That's yes, side A.
Okay.
Sorry, I didn't quite get this entered in yet, but I assume what you said is correct. Sine D is 25, sine D 110. Okay, yeah, at 27.0.
Okay.
But like I said, if you don't like this, you can write like sine 110 to 4 decimal places, sine 25 to 4 decimal places, and it'll work out pretty much the same. All right, so then there's number 12. Number 12 here. Okay. So number 12 here, if triangle ABC, so we'll go A, B, C. If A is 19, that's the one across from it. C is 45 and B is 50. You want to find angle A. This is a law of cosines problem. And to
Oh,
know
okay.
that there's two types. You're either given side angle side or you're given side side side. Side angle side is used to find another side. Side 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 is used to find an angle. So there's a bunch of variations in the way that of law of cosines is written. This is probably the most standard one. You might have seen that in your book, but this isn't very clear. It's not an easy formula to use because it where's A, where's B, where's C, because sometimes they give you the one for B squared, the one for A squared. They're actually all the same. The angle and this side match. So the better way to do this is to realize, okay, you're trying to find A. You want the cosine of big A is what you're trying to find. That means little a squared is going to go on the other side of the equation because these have to match. Do you follow that?
Yeah.
So then what goes here and here are the other two sides. Because if you're finding C, A and B are here, well, B and C are here.
Okay.
Okay, does that make sense then?
Yeah.
Minus A and B match these two letters, B, C.
Oh, okay.
Okay. So now you just to put your numbers in. Your numbers are, you have 19 squared equals 50 squared plus 45 squared minus 2 times 50 times 45 cosine of A.
Okay.
All right, now there's a lot of numbers here. It's up to you, it's up to you if you want to multiply these out. Your calculator can handle all of this if you want. You have to move these two numbers to the other side, so it's 19 squared minus 50 squared minus 45 squared equals -2 times 50 times 45 cosine A. And then you want to bring this to the other side as well. So you divide both sides by it. This is why it's a calculator problem, because there's a lot of, it'd be pretty hard to do this by hand. So it's 19 squared minus 50 squared minus 45 squared over -2 times 50 times 45 equals cosine A. So you get this number, whatever this number is over here, and then A is the cosine inverse of this number here, whatever you end up getting. So I can copy and paste here pretty nicely, and if you can do it all in one step, or you can do the intermediate steps along the way.
Okay. So for that number, I got -0.9.
That's reasonable. So go ahead and punch that in your calculator and see if
Okay, I got 154.16 for the cosine.
so I got 22.3 when I'm all done. Okay. So let me just check this number. At the bottom here needs to be in parentheses. The top needs to be in parentheses. That could definitely mess things up as well. So I get positive 0.925 for this part.
Oh, because it's -2. Yeah. Okay. Yeah, that makes sense. Yeah, okay. I got 25.8 then.
Great. Okay. That takes care of corrections. What else would you like to work on tonight?
I don't have any other homework, so we could
Okay.
just do some like SAT prep.
What about working on any of this? Like, what do you know what your upcoming test classes? What
We're
upcoming?
doing stats and probability right now.
Okay. And then maybe you're pretty comfortable on that, or nothing.
Um, yeah, we could work on that. Just I don't know, some of the word problems are confusing for those, like the
Or do you have an assignment or the chapter review you can send, or something?
yeah, I can send you um one of those slides.
Nice thing is this is it's very different than what you've been doing, so you can sort of reset and
Yeah, it's nice. It's a lot different, so Okay, that should be sent to you soon.
All right, let me check here. There it is. Okay. So we see a PowerPoint here. So I guess I'll just open that up. We'll look at some questions. Okay. Food for class. How can this be unfairly? Okay, box and whisker plots. We should definitely do these. These are generally harder to do for students, especially the ones by hand. So is that okay if I just spend some time on that?
Yeah.
And that's just me speaking from experience of doing this. But what I'm going to do is just look for a worksheet, and we'll do some questions from it so that you you kind of get a feel for what to do here. All right. You can do these on the calculator, but I mean, we've seen you. I guess you have a variety of these. So create a box and whisker plot with the following data. So the first thing is you have to order the data. We can do that really quick here. Here, 2, 3, 3, 4, 6, 6, and 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Since there's an odd number of numbers, where is the median?
4.
Yeah, the median is 4 in this case. So now what that does is it divides up the data set into 2 other odd number ones, which is nice. What is the median of this first set?
3.
It's 3. And how about the median of the other?
6.
6. Okay, so not too difficult so far. So I'm going to just draw a line here. I'm going to call this 4. Quartile 1 is here at 3. Quartile 1 is there at 3. Quartile 3 is over here at 6. Okay, and then we can talk about a few things here. So the median is where the 50% of the data is above or below. This box is 25%, this is 25%, and then you go out to the largest value. And then you go out to the smallest value. And that's the min. The min is 2 and the max is 7. Okay. But there's also 2 things that you have to find: the upper fence and the lower fence. And these are used to determine outliers. Use these to determine if you have any outliers in your data. So you might have seen this in your formula sheet. There's a formula for upper fence and lower fence. You have to first find the inner quartile range. Inner quartile range is Q3 minus Q1. So that's 6 minus 3, which equals 3. So the lower fence, LF, is Q1 minus 1.5 times the inner quartile range. So in your problem, Q1 was 3, or is 3, minus 1.5 times 3, so that equals negative 1.5. And what you're looking for are any values lower than that. If they are, then there is an outlier.
Oh, okay.
The upper fence is calculated very similarly. It's Q3 plus 1.5 times the IQR. 3 plus 1.5 times 3 is 7.5. And you say, well, is there any data points above that? Nope. Okay, and that does affect how you draw it. So you almost have to do this before you draw the box and whisker plot, but you can kind of do it and go back and adjust if you need to on this. So let's do another one here. All right, so create a box and whisker plot for the following set of data. This one is already ordered. What is the median? And there's an even number of numbers this time.
6 and 9.
So it's the average of those two.
Um, 7.5.
Yes. Okay, so the next one I need to just double check. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Q1. Yeah. So this is where it's a little bit different than what we just said. Because there's not a middle number, you cut the data set like this and like this. Except, I'm sorry, I didn't put these in order. We really need to do that. I didn't know. So 1, 2, 5, 6, 7, comma 9, comma 10, comma 12. Yeah, it's my fault because I really wasn't paying attention to this. So the median is right there. The median.
Oh, so it's just 6.5.
6.5. But then you have an even number of numbers here and an even number of numbers here.
Mm-hmm.
Okay, so your Q1 is now the average of these two, which is 3.5. And then your Q3 is the average of these two numbers, which is 9.5.
Okay.
Okay, so now before we draw anything, we really should figure out, are there any outliers? Okay, so the interquartile range is the next thing you want to find. The interquartile range is Q3 minus Q1, which is equal to 9.5 minus 3.5, which is 6. And then your lower fence is Q1 minus 1.5 times the IQR. So the Q1 is 3.5 minus 1.5 times 6. And that is, what is that? Minus 9, so it's minus 5.5. And then the upper fence is Q3 plus 1.5 times the IQR, which is Q3 this time is 9.5 plus 1.5 times 6, which is 9, so this is 18.5. So are there any values greater than 18.5 or smaller than minus 5.5? The answer is
no.
There are not. Okay. So the problem with this worksheet is we don't have one. Let me see if I can find one where there is an outlier, because that's kind of what we're trying to figure out here. Okay, so I'll just make one up because it'll be easier for you to see this, and then it'll help to know what to do. So let's say your data set is 1, 2, 3, 4. Okay, and then we'll go. We'll just say 12. I think that'll do it. Okay. So what is the median of this data set? What is Q1? What is Q3? Right. Q1 is 2. Q3 is 4. So your interquartile range is 4 minus 2, which is 2. So your lower fence is 2 minus 1.5 times 2. It's always 1.5. And then your upper fence is 2 plus 1.5 times 2, which is 5. So notice that 12 is an outlier. Okay, so now we can finally draw one where you have an outlier so you can see how to do this. Okay, so the first thing you do is draw the median. So the median, we'll just call it right there at 3. Got that. Q1 is there at 2. Got that. Q3 at 4. You got that. Okay. Now, the upper fence is over here at 5. That's this right here. This indicates it's the upper fence. 12 though is over here, and you would put a little dot there for 12 to indicate that.
Oh, okay.
Okay. So then this other one, you don't draw. So this is where it's a little bit confusing. You either draw the min, which is what is here at 1. The min is 1. If the lower fence is below the min, you just leave it there. Like you don't show the lower fence going all the way out to 5. You just show it there at 1.
Okay.
So again, what's maybe not clear is that 25% of the data is there, 25% of the data is there, 25% of the data is there, and then
Oh, and that's the
25%.
last.
Yes.
Okay. Yeah, that makes a lot more sense.
Okay, now there's some really good questions that they can ask you for these. Well, I'll just pull something up here real quick. That's this won't take very long to go through, and then we'll do some other stuff related to this. But you have to be able to build a box and whisker plot, and then you might have to interpret what you see here. So before we even answer these questions, you need to know that the median is right there. Like it has to be really clear. Oh yeah, that's the median. Q1 is there. Q3 is there.
Okay.
Okay. What percent of the sophomores spend more than 60 minutes on homework per night? So what's the percentage in this region?
25.
25%. Okay. It's 25% all the regions. What is the range of times at the middle? 50% of the sophomore spend on homework per night. So they're asking what's Q. This is really asking what is Q1 to Q3?
40.
40. 60 minus 20, which is 40. Okay. There's actually only so many things I can ask you here. How many sophomores do not do homework? So they're asking, I guess, down here.
20?
Yeah, I
Is
guess it's
that
20.
right?
I guess it's 20. Yeah, it's a little bit odd because of the way it's written. But at what percent of the sophomores spend less than 20 minutes per night on homework? So they're asking, what's the percentage down here? It's 25%.
Oh, okay.
There's only a few answers. It's only, what's the min? What's the max? What's Q1? What's the median? What's
Yeah.
the percentage? Things like that. Okay, let me go back to that PowerPoint and see if there's anything else here that we can draw from. There are these this table. The table you have, it's the drug survey results. Let me pull something up here. Contingency table. Let's see if we can find one here. All right, let me snip something in here and see if we can use this to work through it. So we're gonna change the numbers a little bit because we don't want to deal with numbers this big. So let's say let's just say that there are 100 people in the population. 30 have the disease, 15 don't. Let's make this 40, and then that's 15 as well. I don't want those numbers to be the same. So let's make this 35 and 20, 20 and 35. Okay. So the first thing is we got to find the totals here. So these would be given to you, or they'd come from this, and the totals you're just adding horizontally. 45, you add vertically 50, 50, 100, and 55. Okay. So I could really ask you anything. I could say, what's the probability that someone has the disease? And you're literally just reading off values from the table. Do you have the disease? Well, 50 people have the disease out of
100.
100. Okay, so that's 0.5 or 1/2. What's the probability of testing positive?
30%.
But there's 45 people that test positive.
Oh.
45 out
45
of,
of 100.
so that's 0.45. Okay, what's another one?
Test negative.
Yeah, what's the probability of testing negative?
55 out of 100.
Yes. Okay, so there's a few of these that we can ask. Now, your instructor, we can also ask things, and maybe this isn't the best table for this. So let's just make up A, B, 1, and 2, 12, 15, 5, and 8. Okay. So what's the probability of not A in this example? So not A means that it's either A or B. Like we don't know what A is. Like maybe A is like hot and B is cold. It doesn't really matter. What's the probability of not A? Well, not A means probability of B.
So it's 2 out of 4.
Well, it's like 1 and 2 is meant, these are categories along here. So let me give you some, I didn't give you totals here. So totals, this is 17, 23, totals here. This is, maybe, let me just say 1 and 2 instead. So this is 27, this is 13, total of 40. So not A means, well, what's the other possibility besides A? The other possibility besides B, besides A is B. That's 23 out of 40.
Oh, okay.
Okay. Now another way to look at probability of not A is 1 minus the probability that it is A. These are the same. So that's 1 minus probability of A is 17 over 40, which equals 23 over 40.
Okay. Yeah, that makes sense.
Right. Now, another thing I could say is, well, what's the probability? Actually, I probably need to copy this up here again for us to look at. I can, I could say, oops, sorry. I guess I grabbed a bunch of other stuff. Okay, let me try this again. Grab just these, copy. Okay, I could ask, what's the probability of 2? Probability of 2 is 13 over 40. If you don't like that, I can change this to, dogs and cats. So the probability of cats is 13 over 40. Is that clear?
Yeah.
So what's the probability of not cats?
27 over 40.
7 over 40. Now it could just be, or it could be 1 minus 13 over 40, which gives you the same thing there. Okay. Now another possibility, and this is kind of what you're getting to in class, it's probability of dogs given that it's A. Do you remember that from your notes? This given.
What does that mean?
So the given means that you only look at whatever A is. So look, A is just this column. So it's like all you care about, your world is A.
Oh,
So how many A's are there?
17.
17. Now how many of those A's are dogs?
12.
12. So what's the probability of cats given A?
5 over 17.
5 over 17. What's the probability of dogs given B? How many B's are there?
15 over 23.
Okay. And then I could ask you the probability of cats given B.
8 out of 23.
Okay. The next thing is I could ask you, what's the probability of A given dogs? Let's see if I can just snip this in here. Yeah, so let me actually move this down. So what's the probability of of A given dogs. So this time we care about, I guess I didn't copy that. This was that cats? Dogs and cats, okay. Dogs and then cats. So now with the given tells you whether you're looking at a row or a column. So now you're looking at this row. How many dogs
Oh.
are there? There's 27. But you only care about the ones that are A.
Oh, so it's 12 out of 27.
That's right. What's the probability of B given cats?
5 out of 13.
5 out of 13. Good. So those are conditional probabilities.
Okay.
All right, now let's go to the one that you've got, and we'll look at one more thing before we close out here. We should get pretty close to the full time for you today. Okay, so let's go. Let's use some things besides. Let's use I, and then N, D, and then P. Okay, just to make this easier. What's the probability of I?
91 out of 160.
Very good. What's the probability of not D? Not D.
Not D. 80 out of 160.
8 out of 160, or 1
half.
minus 80 out of 160.
Oh.
Right?
Yeah.
Okay, so now the one that we've not done up until now is and. So like, what's the probability of I and D? So whenever you see an and means you're looking at one cell. I and D is 67 out of 160 because it's just the one cell.
And okay, yeah, that makes sense.
Okay, so what if it's the probability? What's the probability of N and P? What would that be?
56 out of 160.
Exactly.
Is there an or?
There is. So ors refer to three cells, and there's some overlap. So let's talk about that real quick. So let's say it's the probability of I or D. Probability of I or D. So I or D, the I's are here. So the I's are 67, 24, but the D's are 67 and 13. Do you see how there's an overlap here? You can only count one of them.
Okay.
So it's like an L-shaped thing.
Yeah.
Okay, so you add those three up over 160.
Is it over? Okay.
Yeah.
Got it.
So what if it was probability of N or P? N or P is these three here. It could be an N or it could be a P.
So it's 13, 56, and 24.
Yeah, 13, 56, and 24. Yep. All right. So that is all the time we have for. I thought. So we had something scheduled for last Sunday. Probably the email went to the spam. That's why I didn't see it. When you need to schedule again, I know you've already scheduled for next week. Just let me know and I'll manually schedule it so you can get that time back for you, or let your mom know before she schedules. We can add that back.
Yeah, I tried to join the Zoom, and then so it was for 12, but the Zoom was scheduled for 11, so I couldn't get in.
No problem. So sorry about that. And you know, we'll get back on schedule here. So,
Okay, perfect.
all right. Thanks. I'll see you next time.
Thank you.
Bye now.
Bye.